Connected in 3D, Real-Time Solutions and Digital Twins podcast with your host, Ashley Crowder.
Hi, and welcome to Connected in 3D, Real-Time Solutions and Digital Twins. I'm your host, Ashley Crowder, and I'm here today with Evan Helda, who has been at the forefront of spatial computing for the last 8 years. He's currently a business development and strategy leader at AWS, spearheading BD, partnerships, and go-to-market strategy for all things AR, VR, and real-time 3D. He's also the creator of Medium Energy, a newsletter and podcast exploring all the ways technology can make us more human, not less. And I've had many awesome conversations with you about XR. So I am really excited to actually record one and have you on the podcast. So thanks so much for joining.
Amazing. Excited to be here. It's nice to be in the hot seat. As you know, I have my podcast and usually have to be the one guiding the conversation. So I'm just going to let you hit me with the hard topics and we'll see where this goes.
Awesome. So just to start out, you've been deeply involved in spatial computing for almost a decade. So what initially drew you into the space and how has your perspective evolved?
Gosh, I can't believe it's almost been a decade. That is crazy. I think what initially drew me was just the idea that this is a shift to more experiential computing, right? The ability to do things. I came across a framework recently that I really like. It's called DICE. And it stands for the dangerous, the impossible, the counterproductive, and the expensive. By the way, Rachel Sibley is who came up with this DICE idea, and she has a great TED Talk on it if you want to go look it up. So I don't want to take credit for it, but yeah, big fan of the DICE idea. Dangerous being, the ability to better escape a fire emergency from oil rig, or the impossible, teleporting to Dubai. The counterproductive actually is the one that I like the most, which is this idea of like doing things that can give you empathy, like me being female, me being of a different race, things that you like really just wouldn't really make sense to do otherwise, you just couldn't really do, but gives you a whole new perspective of the world. And then, of course, the expensive things like, selling a train and having someone be in a train. And so the idea of like, those are all just experiences, right? And as a kid, I was a huge gamer and I used to get just completely lost in those experiences alone. But the most important thing that happened to me growing up was that's where I developed my closest friendships, was getting lost in those immersive experiences with someone else. And so it led to like my strongest, best friendships that I still have today. And it was all through this digital medium. And so I think that's what keeps me in the space, is the collaborative experiences that connect you deeper across those different domains of DICE.
Yeah, that's awesome. I mean, it makes sense when I talk with a lot of our manufacturing clients, it always comes up like we need VR or XR because, fill in the blank is super dangerous. It happens infrequently and we need to be able to train people on it, right? And then that XR experience you retain it like it was a real experience. It's a true memory. It's not like watching a video or reading a book. So that's awesome. And you kind of started, I think, at Meta, where you helped build one of the first AR developer ecosystems. Being first sounds awesome, but it's usually extremely challenging. So what were some of the lessons you took from that and how to scale spatial computing today?
Yeah, being a pioneer is fun, but it's a good way, as they say, to have arrows in your back as the pioneer, which is what happened to us. And some people might not even be aware that there was a Meta before the current Meta. Meta was a startup. The best corollary, it's a spitting image of our story, is that of General Magic. And so if anyone's heard of that documentary, they'll get it. But if you've not seen General Magic and you're passionate about this industry, that's the best documentary that exists, I think, to kind of explain where we are today in this adoption cycle for XR. But Meta was basically building the Apple Vision Pro back in started off in 2013, 2014. I joined 2016. General Magic is the story about a company trying to build the iPhone in the 80s and 90s. So that's the parallel. But yeah, our vision was a powerful one, and it's a part of the answer to the first question. Um, and the vision was, look up from your screens, right? And build a more natural computer interface that conforms to the way that we interact in the world with our eyes up and the way that we process the world, which is spatially. And that would lead to much more natural human computer interaction with a much lower learning curve. And we were trying to build applications that were inherently spatial. But that what I mean is we were fighting a lot against this idea of like skeuomorphism, taking old UIs and 2D panels and iOS work, UI UX and pulling it into a spatial environment. We were focused on building apps that mimic the real world, such that if you had like a painting app, it wouldn't just be like a painting icon and then you click on that and then you'd have like a cursor that you paint with. You'd literally have like a bucket of paint and a paintbrush, and you'd go and you put a paintbrush in there, and it would literally one-to-one mimic how you do it in the real world. But the main lesson there is, trying to do everything when you're an early startup is a recipe for disaster. Try to build a full tech stack. We tried to build our own computer vision algorithms for SLAM and for hand tracking. We tried to have an SDK. We tried to build our own optics engine. We also tried to build our own OS and our own applications to do all that spatial stuff I just mentioned. And they were all okay, but they
Yeah.
weren't the best of breed at each layer, right? And so we just kind of had this mediocre product that just didn't quite meet up. But I don't think that would have mattered. I think we were just too early, right? Like the hardware just too big, too bulky, and too expensive. And we're still kind of in that same place. You
Yeah.
know,
I mean,
it was a $2,000 headset. The Vision Pro's $2,000 headset. Now it's way more capable, but
yeah.
I have it right here, and I've used it once in the last like 4 months, which is sad.
Yeah, I know. So I mean, you built everything because you had to. There was
Yeah,
nothing out there. So yeah, timing is everything. It was a bit too early, but to your point, I think, um, especially as a startup, you have to focus. I mean, Magic Leap, it's really I mean, they raised billions of dollars, and it's going
exactly.
to
Just
the
didn't matter. Wouldn't
same thing.
matter, right? Yeah.
But I am hopeful with Google launching Android XR to
Mhm.
have that standardized platform to build on. They're really great at platforms. We're on Chrome right now, so hopefully that simplifies thing. And yeah, to your point, everything needs to be uh, best in breed and focused on. Um,
Mhm.
but yeah, headsets are still expensive. They're bulky, and that's why at least our focus has mainly been on B2B because you're not embarrassed to wear that headset for an hour at work if it's going to help you do your job better, and
Yeah.
other people are wearing it.
Totally.
But yeah, I mean, and now we also have incredible cloud compute, which helps. Obviously now you're
Yeah.
at AWS, which is playing a
hmm
massive role in real time 3D applications. So how are you all defining spatial computing, and how does it fit into AWS's broader cloud strategy?
Yeah. So we're defining it more broadly than just AR, VR, right? We like to think about it as this spectrum of interfaces that can perceive the world and simulate the world in some form or fashion. So that could be as non-immersive as just 3D commerce on a website, but there's a game engine there that's simulating how the world works in some form or fashion, and then all the way to the middle of like mixed reality and AR, or even in between that, which would be just like a full game engine simulation on a browser, right, of a virtual factory, and then of course all the way to the full side of the spectrum of full immersion. Um, but we also are starting to take into consideration just any devices that process XYZ coordinates and localize either a user or a machine in space. So that includes robotics, that includes drones. These are all perceptual systems. And you look across the XR stack and the robotics stack and the computer vision stack, it's all the same back end for the most part, just different looking front end. And so we're trying to come at these systems and find like the unified architectures that they all require to build what we call a spatial data plane. This is our fancy version for kind of what you guys do, right? It's um, basically from this is cloud terminology. It's ingress, storage, and egress, and lots of workloads fall under each of those three categories. But what we see is that enterprise organizations just don't have spatial data planes figured out.
No.
Um, but look who does. It's game studios and visual effects companies, and like they have all that nailed. A lot of it's on prem though. Even they don't have the cloud part figured out because they started building before the cloud became the right place to do it. And that's the opportunity for the enterprise space, right? They're all building experiences that require them to look and feel like a game studio.
Yeah, I
Um,
mean, I love
yeah.
that. That's what I talk about all the time. This isn't just a headset, isn't just AR for shopping. It's
hmm
we now can have 3D and volumetric content on
hmm
all different types of devices, and I love that explanation of anything that can have XYZ coordinates because the internet to date was built for 2D and now we're in 3D. And
Yep.
how your Microsoft OneDrive and Dropbox, it all was built for 2D. And we need to upgrade these systems to handle this massive 3D volumetric spatial content, which there's a lot of challenges there. So, what are some of the challenges that you're seeing, and how are you all going about solving it for people?
Yeah. Guess there's few. I'm trying to think about how to best bucket them. Um, I guess the first challenge when you come into these engagements, it's a chicken or egg problem in which having a good spatial data plane strategy, we'll call it, um, is not a small endeavor, and you have to have a good reason to go do it. And so few customers are at the scale with 3D where there's a enough pain yet to then go solve the spatial data because the spatial data plane is a scale mechanism. So that's the first problem is like, how do you go and create the demand function for the spatial data plane? I'm sure you experience that a lot of time, a lot, but that's why you're focused on e-commerce because that is where that demand equation is kind of already being solved, right? Because they are getting actual business value out of 3D on the web. Um, but for the companies that do have figured out and are trying to get to that level of scale, I think the first one is just uh, a data hygiene and like data organization problem because they're starting to capture spatial data from numerous disparate sources. Like for a long time, it was just like CAD systems, PM systems, but now it's CAD. Now it's point cloud capture sometimes. Now it's like Gaussian splats are being produced, and then you have all other teams out there building things from scratch in like a Blender or a Maya. It's disparate from the CAD and PL. So you have all these disparate sources of data, and they don't have a good way to like, capture it all and ingest it in a singular pipeline, if you will. And then from there, it's the sort of connection between those sources of data, and then we'll call it like a version control or updating down the whole value chain, and vice versa. So like if a change happens upstream to an asset, and then someone downstream is working off a different asset, like
Yeah.
having the right updates flow through that value chain so they're working off the right thing, and like that most recent change that's relevant for the marketing team or the operations team actually does get back down, and then pushing those insights and information and changes all the way back up to the system, right? That's one of the biggest challenges we see. The third challenge is just kind of looking around corners, um, but they get this data together, they get excited about it, and then they go do after a use case, and they realize, like, oh wow, like, I need a lot more context tied to this 3D data.
Hmm.
Like I need something more than just dumb polygons and pixels. I need this data to have some business intelligence tied to it. And so I've been calling this idea like data ontologies or spatial ontologies. And it's this ability to map relationships between the polygons and pixels and the part numbers, the bill of materials, maybe it's IoT data, maybe it's some kind of other ERP data, supply chain data, whatever it is based on the use case. There's no good way to easily pull that data in from disparate sources, map it to common, we'll call it an entity, and then have the right relationships and like hierarchy between that data and the asset. And then you take that idea and then you try to solve that. You try to map that to the last problem I mentioned before, which is this data through the value chain. And oh my gosh, it can become a nightmare. So like the question becomes, how do you automate? How do you gather that data? How do you automate the mapping of that relationship between business data and visual data? And then how do you keep it updated in real time?
Yeah.
That's like the macro level pain point that everyone's running into, or they're about to run into as they move into this digital twin first world.
For sure. And yeah, we've actually, our fastest growing segment is industrial manufacturing because to your point is what is that value? Yes, ecom saw it first. They were forced with COVID of needing a better way to sell online, but industrial is realizing if they can run digital twin simulations with real-time data, they can make better decisions, right? And
Yeah.
it's saving money, and predictive maintenance is saving hundreds of thousands of dollars because if your factory goes down for one day, huge cost.
Mhm.
And so being able to tie that data to real-time information, and there's some incredible people like DFW actually has an incredible real-time digital twin with information being pulled from all over the airport. I was really impressed, but they're still trying to figure out the 3D visualization part, right?
Mhm.
Tying that all together is hard, and that's what we're trying to do too. And as you mentioned, that you've got 3D, all different types of 3D file formats coming from all different places, which is why we're excited about like implementing our model ops and optimization into to AWS to be that,
Mhm.
is we're solving that one problem to your point, at scale. But going into that, I mean, we just talked about so many different use cases. Like, what are you seeing most frequently across, the need for this spatial computing data plane? How are companies leveraging this technology in their business?
From like an end user use case perspective, you
Yeah.
mean? Yeah, yeah. There's really three broad buckets that we're focused on. I think anyone who works in the space is going to be like, yeah, no, duh. But I'm going to assume maybe you have some laymen that listen to this. Um, the broadest bucket is just we'll call it advanced or immersive visualizations of some type. And that's the basic stuff like a design review or like a B2B sales experience. Like I mentioned, the example of selling a huge train earlier, um, or some of the e-commerce stuff. That one, that one's out there and it's common, but we're not seeing people uh, easily tie business ROI to it. It's kind of nebulous. It's hard to measure like the impact of like a more immersive design review or like a more experiential um, presentation. Like, yes, in theory, you could measure a faster conversion rate on a sales cycle or faster design review cycles, but like I don't see anyone actually producing that data easily,
Mm-hmm.
right? So they're not able to take it and then go big with it and internally. What's different is on things that are more like simulation oriented. So the use case you mentioned earlier, like the most common thing we're seeing in manufacturing is like these virtual factory build outs. Like that's where you have these big dollar amounts to these greenfield factories, especially in the battery space. And time matters. Time is money in the biggest way, and they're all sprinting to build these out. And so they need much faster ways to like stand up these factories. And that's where they do have the capacity to like measure and know that they're able to go from concept to factory floor layout to then implementation. And that if they can shrink that front end of that much faster because they're coming into virtual space and they're putting that machine here and this robot arm there, and they're getting sign off from people around the world here and like, yes, go. That's something we're seeing that's pretty common across like automotive and aerospace and even for oil and gas, for like refineries and doing like virtual commissioning of new refineries. Um, I think then what people are starting to wake up to is once they have that foundation, um, that becomes a digital twin, not just to make decisions in for humans, but also for robots. And so this is where I steal the quip from Jensen Huang, where he talks about his ideas like digital twins are where robots go to learn to be robots. And these environments are the perfect place to go and drop in some kind of computer vision system to like train, build in semantic awareness and understanding of that space. And so that's the other interesting overlap and use case we're seeing people do. And then I guess the third use case is tied to that, where you have that digital twin of that environment. You're using it to build the thing physically better. You're using it to train the robot better. And now people are realizing, oh, we can also use this thing to train the humans better
Hmm.
as it's built, to hire them to go in there and actually do any human-based task better. But the problem we're seeing though is that there's disparate teams doing each of those. They're all building the same kind of virtual world with the same 3D assets, the same workflows, but they're all building it in their own way with their own 3D assets, their own version of it, and there's no unified workflow behind any of it. So that's the holy grail for these companies, is like build it once, deploy it anywhere. Have one pipeline, one workflow, one CMS. This is kind of why you guys exist, to feed all those with the same source of truth, versus having these disparate teams working off disparate models in disparate ways with like different UIs, different UXs, different tools. It's just a complete
Yeah,
mess.
when you work with big enterprises, like the left hand doesn't know what the right hand's doing sometimes.
Yeah.
But going back, your oil example, my first job was at an oil refinery actually, and
Hmm.
turnarounds are when they have to shut down parts of the refinery and clean them, do work. I don't know why there's a random thumbs up. Uh, it's extreme. Like going back to your dice example, it's extremely dangerous. It happens very infrequently, and we would spend months planning and having to try and think of all the different scenarios that could go wrong and have contingency plans. But if you can run that through a real-time simulation beforehand,
Hmm.
it can be incredible. Um, lives you can save and time and dollars, which is great. And then with training the robots, it makes total sense, right?
Hmm.
Uh, and something one of our clients is doing now is even using AI to create synthetic data to train the systems on, which is
1,000%.
wild. So leading into that, I mean, AI is obviously like a huge part that's enabling XR, I think, to
Mhm.
finally take off. So
Totally.
how are you and AWS integrating AI into spatial computing solutions to help make this easier and faster?
Um, I'll be honest and say that it's not really happening yet. It's kind of all like we all know that's opportunity. Um, it's happening a little bit. So there are some prototypes getting built, but it's more conceptual. But the areas where we see it working are threefold, maybe more. Um, One is faster configuration of existing 3D assets. So it's not generative, producing a net new thing. But you have a repository of geometry and polygons of different versions. You want to reconfigure those in a certain way using an LLM to just go and do that configuration. And same story for like scenes. So you have a scene, you have some basic framework for that scene, could be in different formats. Um, Rather than having to go into Unity and like drag this object there and that entity there and create that relationship here, you're just using language to do all of that. And then this isn't really happening yet, but the thing that I'm excited about is exactly what you just mentioned. Like once you do have a spatial data plane, you do have that data properly organized, be it 3D assets and be it the context of those assets, you now have an opportunity for AI to reason about that data. If you didn't do that, AI agents can go in there and understand what's what and have context as to what to do with that asset in the right way, right? Or how to even find the right asset. And so I think once you have data with context, you can now have agents do so many things, right? And there's like a huge long tail of use cases from the app development to even just like on demand, all the on demand stuff for like frontline AR worker experiences, right? So you walk up to a machine and there's a problem with it, and you have to say in real time, hey, pull me up all the machines with XYZ part number um, based upon this parameter and give me the work instructions for this problem. And like if you don't, if the data is not organized properly, an AI agent can't go in there and pull that data all together and then spin it up into a work instruction in real time. Right. So that's another super exciting use case. And then
Yeah,
the
and
other one is, yeah, go ahead.
I was just I just heard this quote recently, and I don't remember who said it, so I will have to give context later, but we're drowning in data and yearning for wisdom, right? So
Hmm.
it's being able
Hmm.
to, or to your point, like organize all this data. And we've actually had some clients use Ventana to train ML systems, to your point, because you need organized data, organized 3D models with the proper metadata to be able to train properly and then get meaningful, measurable, information where you can make better decisions. That's the
Yeah,
goal, right?
exactly. Yeah. It's all about making a decision for the most part, at the end of the day, whether it's an AI making a decision or a human. And that's if I had to succinctly give one so what for spatial computing, it's probably that.
That's awesome. And I love that you brought up like AI powered assistants and agents interacting with spatial environments.
Mhm.
Do you see this as an inevitable part of the future? Do you see people doing it today?
Of
Is it
course,
still,
actually, that's why I'm still here after 8 years.
is it
No,
everyone's
I'm
still
kidding.
experimenting? Do we not know what we're doing yet?
Oh, um, I think for the first time, the companies that have been like sludging through the mud for the last 5 years, the ones that like bang their head against every headset and every game engine and every different startup, like some of those projects got shut down. They're like, hey, the space isn't ready yet. But the ones we've seen that have kept like fought through it, they're finally pushing some things into production now. And so I think it is inevitable. I think it's inevitable that, and like those companies are going to production. They're all coming out the other side with a pretty similar tech stack.
Hmm.
It's just all very duct taped together right now. And it's all disparate tools, disparate UI, UXs, like disparate data pipelines, like I mentioned. But I think that like that was the early that was the pioneers, and they indeed have arrows in their back, right? Like I did at Meta. Um, but that's where the early majority is going to be able to benefit from. They're going to learn from, like, you're going to start seeing stories that come out. A good one is ExxonMobil. They're out there talking about their Dre platform pretty incessantly. You can go on YouTube and type in ExxonMobil Dre, and like that's it. They've been at this for so many years. They've narrowed it down to the most essential things, and like that's the story. And until companies build out a similar thing, we're going to be stuck in this like pilot POC purgatory. But the ones that are doing what Exxon's doing are actually the ones going to production. So I think they are going to follow after those leaders and innovators, and I think it is inevitable.
Yeah. Well, I agree. That's why I'm still in this too. I thought we'd already be there, but we're getting there. And some of the things you touched on, with these large scale simulations, you touched on the idea of this like persistent virtual world that's consistently getting real time data, spitting things back out. How do you see AWS helping enable this kind of massive, always on virtual environment?
Well, I think I should maybe backpedal a little bit because I'm not necessarily convinced there should be just one always on virtual environment. I think we might get there, and like that's the vision that the Siemens of the world tout with their recent NVIDIA Omniverse partnership. Um, but I think people are quickly realizing how unrealistic it is to have one virtual world that is one to one across every dimension enough, and stay up to date enough to actually be that thing for all the use cases there. So like earlier, what I was saying, it was not so much that you need to have one virtual world and then everyone's in there doing their own thing. It's probably more of like what you see in games, where like there's different shards, if you will.
Mhm.
Um, the more common thing people are working off of is the same workflows, data, and assets, and like maybe authoring tools. But I think you are going to see, like a very basic, purely visual virtual factory over here. It's just for like the, we'll call it factory layout use cases. That isn't going to be like the one-to-one same factory as the one over here is being used to train robots. It's going to be like a separate thing just with the same assets, but like very different, like separate kind of server, if you will, and little mini architecture for that use case over here. And so it's going to be sort of like, what's the uh, many worlds theory for quantum mechanics? It's going to be like that, I think.
Nice. Yeah, I mean that makes a lot of sense. So ideally, using the same building blocks, but to be able to take bite-sized pieces out of this whole problem,
Exactly.
that makes sense. Like build
Bunch of
a
derivatives. Yeah,
lots.
there is probably like a master file of some kind, and that
Mhm,
there are use cases that will want to go into that master file, and in this case, maybe we'll consider it the USD file, which is a file of files, right?
mhm.
Um, if USD becomes that, we'll see. It's trying hard. But yeah, agreed. It's you're gonna have like a master and then derivatives spinning off of it.
Yeah. No, that makes sense. And so we've talked a lot about, oil, gas, manufacturing. I mean, over the next 3 to 5 years, what industries do you see adopting this the fastest?
I think you're going to see the defense and aerospace world accelerate. Um, One compelling reason why is there's this DoD directive. It's called the Digital Engineering Directive, and I forget the exact string of numbers, but you can type in Digital Engineering Directive and look it up on like Perplexity. But it's the first time where they're demanding that any new weapon system program or like just program with vendors like the Lockheeds and Northrops, the Raytheons of the world, that they share and give access to all the digital product information.
Hmm.
That includes 3D and everything else with it. Guess what has to exist to do that well? A spatial data plane or a Ventana, right? Of some kind. It has to be like GovCloud secure, and it has to do the handoffs in the right way. Um, and so I think that's a space. I think you're going to see companies in the aerospace world try to follow suit and adhere to that directive. You're going to see the DoD orgs do the same thing. Um, what's another space that's going to follow suit around this? I mean, there's the obvious one. Like one of the ones where there's the most pain, similar to oil and gas, is like power and utilities. It's a very
Hmm.
similar problem. Like lots of physical infrastructure, lots of brownfield places. And the ones that have the most pain is where there's the most disparate data. Like if you go to like a Nike or even the automotive companies, so much of their data does come from the CAD and PLM system. And so it's not as acute, or it's not as like thorny or much of a spaghetti of a problem. But for power and utilities, energy too, there is CAD, there's PLM, there is also lots of scanning from lots of devices. They have
Yeah.
robots out there, they got drones out there, and they can't synchronize this data in any really meaningful way. You got assets living on like filed, like shared file folders. You got assets living on like in lockers on a hard drive in the locker,
Yeah.
and I think that's another one where you're going to see a lot of this happening. And I think in general, um, we are seeing just a big push for like onshore manufacturing, and so a lot of like engineering construction companies that are the vendors of the autos and the arrows of the world that are building out or these data centers. I think data centers is a huge one because there's a huge gold rush to build out these AI data centers. It's the same kind of thing as like the factory commissioning stuff. And I guess the last one I'll say similar is like this like general semiconductor space. Like they have some of the most complex machines. Like take an example like Applied Materials, incredibly complex multi-million dollar machines, and the ability to like better sell, better build, better design those as the demand for them flies through the roof you're going to see a lot of demand there too.
Yeah. I mean, every manufacturer's goal is, better, faster, cheaper. You can normally only pick two, but if you've got AI and virtual twins, I think it helps that. And then, to your point on utilities and oil, that, no two refineries or utility places are the same. They're all slightly custom built. And I think any of those enterprises where you have multiple customized solutions, you run into this huge spaghetti problem, as you said, with all the data. Um, well, this has been so great. I mean, looking ahead, my last question, because I know you think about the future a lot. In 10 years, what do you think will be the defining breakthrough that pushes spatial computing to the mainstream, that gets us out of this
Hmm.
duct-tape solution and everyone's live doing it?
Generative UI. It's not generative AI, but generative UI, meaning Not just like, of course we need the AR glasses and the form factor to come down, and that's an obvious thing that has to happen. But I think until we have a computer vision system and the AI be able to intelligently display like the most tiny minimal amount of information based upon who we are with and what we're doing and what we're trying to achieve, such that it is better than kind of being stuck down here in the phone. Because like my biggest fear, like there's a paradox here for me. Like I love this space for those dice reasons we laid out earlier. Shout out Rachel Sibley, by the way. She's the one that thought of that dice concept. She has a TED talk on it if people are curious. But yeah, I guess just to put it more succinctly, like until the UI can adapt, right? Oh, yeah, I know what I was gonna say. Rachel Sibley, it's a dice thing. She and I were talking last night about how like fearful we are of just like this on our face, and just how like this tech can have a lot of downside if we don't do it right. And there is a lot of problems with like always on information. And so I think until we can, I think unless we figure out a way to use tech to defeat tech, this is a big thesis of mine. This is the big reason why I have my newsletter and podcast, is like we got to find ways to use tech to combat tech. And that to me is what generative AIs can do, is that you can like, if it can be plugged into your well-being in some kind of way, it's going to know when you're overly stressed or anxious, and it's going to know when you don't need, you should not be plugged in. It's going to tell you, hey, stop.
Wow.
Like your heart rate is spiking right now. Your whatever biometrics are telling you that you're overwhelmed. Like I'm not going to give you AR information right now on XYZ because you need to go for a walk in nature, damn it. So get out there and go do it. Like that's a crude example, but that's kind of the idea that I'm thinking of here.
No, totally. We need the right information to the right people at the right time.
Yeah.
That's the goal. Well, love your insights. You've got so much knowledge in the space. Where can people go find your podcast and newsletter and reach out with more questions?
Yeah, appreciate that. The newsletter and podcast is Medium Energy. So it's mediumenergy.io. And yeah, I try to release an essay monthly. It ends up being like quarterly at this point. So I need to pick that up. But the podcast is at least monthly. And yeah, we dive into the convergence of spatial and AI and how to make sure we can build these things such that they, as you said, make us more human, not less. And so that's where you can find my stuff.
Awesome. Well, Evan, thanks so much for joining. Excited to continue working with you, and see you all next time.
Sounds good.